Morning, dear student. In previous lecture, we discuss uh, the simple lipids, that is fats or oils, and the some part is remain, that is the waxes. So these fats or oils, these are nothing but the esters of fatty acids and glycerols. So they are considered as the triglycerides. So we already discussed the properties of fats or oils, and the waxes are remaining. And then in today's lecture we are very much interested in the compound lipids. So what are the different types of these compound lipids and their structure? So we are very much interested in the compound lipids, their properties and their structure. So before discussing the compound lipids, you should remember some points regarding to the waxes, because the fats or oils we already discussed. Their data identification we also discussed, that is a saponification value, then acid value is there, iodine number is there. Okay, all these terms we already discussed. So this waxes, so it is also the type of compound, it is also the type of simple lipids. So these waxes are the esters of fatty acids with higher alcohol other than glycerol. So before discussing these compound lipids, so let us discuss some important point regarding to the waxes. That is, it is a type of simple lipids. So these waxes are the esters of fatty acid, ester of fatty acid with ester of fatty acid with higher alcohol, with higher alcohol other than glycerol. So this is the difference between the fats and the waxes. So in the fats, the alcohol part is glycerol. So in this waxes, the esters, it is the ester of fatty acid with higher alcohol other than glycerol. Second important point is that, so this is your first. Let us discuss the second. That is, in the human body, the common wax are the ester of cholesterol. So the example, the human body, common wax in human body, common wax in human body is the ester of cholesterol, ester of cholesterol. So in the human body, the common waxes are the ester of cholesterols. Again, they are mainly three types. So these waxes is of three types, such as the first one, that is the true waxes, which are the esters of higher fatty acid with acetyl alcohol or other higher straight chain alcohols. So these waxes are classified into three types. So they are having three types, in which the first one is the waxes are the esters of fatty acid with acetyl alcohol, ester of fatty acid with acetyl alcohol, ester of fatty acid with acetyl alcohol. Second, the cholesterol ester are the esters of fatty acid with cholesterol. So we are not goes into the details, the structure, but at least you should know these waxes, these are the esters of fatty acid with higher alcohol other than glycerol in human body. The common example of this wax is the ester of cholesterol. So the waxes of three types. One is the ester of fatty acid with acetyl alcohol. Second, the cholesterol ester, cholesterol ester, that is the ester of fatty acid with cholesterol. And the third one, that is vitamin A and vitamin D esters of palmitic and stearic acid. So vitamin A and vitamin D, vitamin A and vitamin D, esters, esters of palmitic or stearic acid, palmitic or stearic acid, stearic acid. So this is all about the waxes. At least you should know the difference between the fats and waxes, then the common waxes which is present in human body, and there are different types. Let us discuss. So we are very much interested in the second type of lipids, that is the compound lipids. That is the compound lipids. That is the compound lipids. The first one, the compound lipid, is the phospholipids. Phospholipids. The compound lipids in which we discuss the first one, that is phospholipids. So what is this phospholipids? This phospholipid, it is also known as phosphatides. So this phospholipid, it is also known as phosphatides. It is also known as phosphatides. So they are the esters of fatty acid with glycerol containing an esterified phosphoric acid and nitrogen base. So these phospholipids, it is a combination of, or we can say they are ester, they are ester of fatty acid. They are ester of fatty acid with glycerol. They are ester of fatty acid with glycerol containing an esterified containing an esterified phosphoric acid and a nitrogen base. So this phospholipid, it is also known as phosphatides. So they are the esters of fatty acid with glycerol containing an esterified phosphoric acid and a nitrogen base. It is not it is and a nitrogen base. They are present in large amount in nerve tissue, brain, liver, kidney, pancreas and heart. Again, if you see the biological function of these phospholipids, so let us discuss some function of these phospholipids. So this what is the function of these phospholipids? So they increases the rate of fatty acid oxidation. The first function is they increases the rate of fatty acid oxidation. So this is the important function of these phospholipids or phosphatides. They increases the rate of fatty acid oxidation. Second, they also act as a carrier of inorganic ion across the membrane. So carrier of inorganic ion across the membrane. Again, the third important function, they help in blood clotting. They help in blood clotting. Again, the fourth important function of these phospholipids, that they are act as a prosthetic group to certain enzymes. So they act as a prosthetic group They act as a prosthetic group for different enzymes. They act as a prosthetic group. So we already discussed the prosthetic group. That is the very common example of this prosthetic group is hemoglobin, in which heme it is your prosthetic group, and there is a globular part of protein. So these phospholipid, they also act as a prosthetic group for different enzymes again. So this is regarding to the function of these phospholipids. So at least you should know this phospholipid is also known as phosphatides. These are the esters of fatty acid with glycerol containing an esterified phosphoric acid and nitrogen residue. The function of this phospholipid, that they increases the rate of fatty acid oxidation. Second, they act as a carrier of inorganic iron across the membrane. They help in blood clotting and act as a prosthetic group for different enzymes. So let us discuss the classification of these phospholipids. Classification of these phospholipids. Classification. Classification of phospho classification of phospholipids. The classification is based on the type of alcohol present in the phospholipid. So whatever the classification is there, it is based on the classification is based on the type of classification based on the type of alcohol group is present. Alcohol group is present. Alcohol group is present. The classification is based on the type of alcohol group is present. So they are classified into three types. They are classified into three types. The first one, so these phospholipids, you can write here, they are classified into three types. First one is the glycerophosphatides. Glycerophosphatides. Second one, glycerophosphatides. Second one is the phosphonosides, or the first one is glycerophosphatides. Second one is phosphoinositides. Phosphoinositides or inositides. Phosphoinositides or phosphoinositides. And the third one, that is the phosphosphingosides. 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 So at least you should know the meaning of these phospholipids, their function and their classification. This classification is based on the type of alcohol group is present. They are classified into three types. First, that is glycerophosphatides, in which glycerol is an alcohol group. So you should remember why they are called as glycerophosphatides, in which glycerol is your alcoholic group. Again, the second one, that is phosphoinositides, in which the inositol or inositol is the alcoholic group. And the last one, that is the phosphosphingosides, in which the sphingosine is an amino alcohol. The sphingosine is an amino alcohol. So this sphingosine, it is an amino alcohol. So glycerophosphatides, then phosphinoinositides, and then the phosphosphingosides. So the first one contain glycerol as an alcoholic group, second one contain inositol or inositol as a functional group, and the third one, that is the sphingosine amino alcohol as a alcoholic group. Then if you see the example of this glycerophosphatides, then there are different example, that is phosphatidyl ethanol amine. The first one is phosphatidyl ethanol amine, phosphatidyl ethanol amine, or it is also known as cephalin. So you should know the name, that is cephalin. Phosphatidyl ethanol amine, cephalin is there. So let us discuss one by one. So we will discuss the name and the structure. So let us discuss the first one, that is glycerophosphatides. That is glycerophosphatides. Glycerophosphatides. The example, the first one is phosphatidyl ethanol amine. Phosphatidyl ethanol amine. Phosphatidyl ethanol amine. It is also known as cephalin. It is also known as cephalin. If we see the structure of this phosphatidyl ethanol amine, it is an example of glycerophosphatide. So the structure is CS2 O, C double bond O, the R1 group is here, again CHO, C double bond O, R2 group is there, and it contain CS2, it contain the phosphate, that is P double bond O, O minus, again CS2 and H3 positive. So this is the nitrogen base. Okay, it is a nitrogen base residue, it is a phosphate residue, and this is your the alcoholic group is glycerol. Okay, so esters of glycerols and fatty acid also containing the phosphoric acid residue and the nitrogen bases. So this is the example of glycerophosphatide, phosphatidyl ethanol amine. It is also known as cephalin. Okay, the another example of this glycerophosphatide, it is phosphatidyl choline is there. Phosphatidyl choline is there. It is also known as lecithin. It is also known as lecithin. Phosphatidyl choline is there, lecithin. If you see the structure of this lecithin, so the difference, if you see the difference, is that this group is same. What is the difference? Again CS2O, P double bond O, O minus is there. So what is the difference? The difference is only the nitrogen base, that is CS2 N CS3 CS3. So this is the difference. If you see the difference between these two structure, the difference only the nitrogen base. In the first one, that is CS2 NH3 positive, it is the nitrogen based in cephalin, and in second one the CS2 N CS3 twice, this is your choline residue. So this part, this CS2 N CS3 part, it is your choline residue. So this is your choline residue. So you should know the difference. Phosphatidyl ethanol amine, second phosphatidyl choline. So it is the esters of fatty acid, in which the alcohol is your glycerol, but along with fatty acid and glycerol there is a phosphoric acid residue and the nitrogen bases. So in this case the nitrogen base is cs2 nh3 positive ethanol amine is there, and in this choline is there. So this is the second example of this glycerophosphatides. One more example of this glycerophosphatides is the phosphatidyl serine. So let us discuss the next one, that is phosphatidyl serine. The third example is your phosphatidyl serine. So we are very much familiar with this serine. So it is an amino acid residue. So if you see the structure again, cs2o c double bond o r1 is there, again here cho c double bond r2 is there, and here cs2o p double bond o oh is there, o cs2 ch nh3 positive and coo minus group is there. So this is the example of this phosphatidyl serine. So this is your ch2oh r group of this amino acid. So nh3 group is there, acidic group is there, one hydrogen is there, and one ch2oh. So uh, so this is your serine residue, okay, and therefore it is considered as a phosphatidyl serine. Again the alcohol group is glycerol, so you should remember the example of this glycerophosphatide is cephalene, lecithin, and then phosphatidyl serine. One more example of this glycerophosphatide is the phosphatidic acid. Phosphatidic acid. Phosphatidic acid. So it contains only the phosphoric acid residue. It does not contain the nitrogen base. So let us discuss the example of this phosphatidic acid, that is your cs2o c double bond o r1 is there, again cho c double bond r2 is there, and here cs2o p double bond oh is there. So phosphoric acid residue is there. So p double bond oh group is there. So phosphatidic acid. So these are the example of glycerophosphatides, in which glycerol is an alcoholic group. So along with fatty acid and glycerol, so there is a phosphoric acid residue as well as some nitrogen bases. Let us discuss the second one, that is inositides. Phosphoinositides. So this is these are the example of glycerophosphatides. Let us see the second type, that is phosphoinositides. Phosphoinositides. Phosphoinositides, in which the alcoholic group is, in which phosphoinositides, in which the alcohol group is inositol or inositol. The alcoholic group is inositol, and the example of this phosphoinositides is the phosphatidyl inositol. And the example phosphatidyl inositol. It is also known as lipositol. And if you see the structure of this, that is cs2o c double bond o r1 is there, again cho c double bond r2 is there, again cs2o p double bond o which is there, again this oxygen H. So 6-membered ring is there, and here OH, H, OH, H, then H, OH is there, OH, H is there, then H, OH is there. So this is your inositol residue, phosphatidal inositol, or it is also known as lipositols, in which the alcoholic group is inositol, no doubt, in which the alcoholic group is glycerol is also there, but uh, for for simplicity or our convenient, they are considered the inositol as an alcoholic group in these phosphoinositides. So alcoholic group, it is not glycerol, it is considered as an inositol. And the third one, that is the phosphosphingosides. Let us discuss the next one, that is phosphosphingosides. Phosphosphingosides. Phosphosphingosides, in which sphingosine is an amino alcohol. Sphingosine is an amino alcohol group. Amino alcohol. And the example of this phosphosphingosides is the sphingomyelin. 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 If you see the structure of this sphingomyelin, and then the structure CH3, CH2 12 times, then CH double bond CH, then CH OH is there, then CH is there, NH, this is our CH2 O, then it is attached to P double bond O, OH is there, O, CH2, CH2, N, CH3 twice, NH, C double bond O, R. So this is the structure of this sphingomyelin. So if we see this framework up to this NH, so this is your sphingosine residue, one more the phosphoric acid residue, and the last one is choline residue. So this is the example of phosphosphingoside, in which sphingosine is an amino alcohol group is there. So this is all about the phospholipids. So it is an example of compound lipid. In next lecture we will discuss the second type of compound lipids, that is glycolipids, and the remaining part of this chapter. Thank you.